this is actually the final section in this chapter, which means we are approaching a test on this stuff. I'm thinking,
Let's have 4 days to.
well,
Yeah.
this section is pretty short. So probably Tuesday and Wednesday, I might take 2 days to review, so test on Thursday, if that's okay.
Yeah.
So the quiz you just took has the majority of what's on your test. You know, being able to graph it. This is just kind of solidifying some of that and showing you some easier ways. So we've talked about graphing these polynomials. And we know that in order to graph them, we have to have it in factored form. So we can find the zeros and know a way to plot all that on the graph. And we've been doing P's and Q's and possible zeros to do that. But I don't want you to have the misconception that you always have to do P's and Q's. Remember, anything I taught you up till now still works. So if I gave you this problem, you could certainly do P's and Q's and possible zeros, but we know that process takes a little while. Does anyone know of a shorter method to do this?
Graph it and look at the zeros.
Okay. Think about things that I've taught you previously. You had actually solved this type of problem before I ever taught you P's and Q's. We had these back in an earlier chapter.
You're really.
Is it so much zeros?
And you can't use the excuse of your A plus or something.
Yeah.
You're just.
So we can solve this by factoring. If there's 4 terms, how did we factor?
Oh yeah, with the left first.
Yeah, we did grouping. So we could put the first 2 together. But remember, I told you don't ever put a parenthesis after a minus sign, so make that a -4 first, and then put your parenthesis. -4x minus 12. So then, how would you factor?
X squared.
And that leaves you with,
X plus 3.
and the second one?
Take out -4.
Yeah, we're left with x plus 3. And remember, grouping works if these have that same parenthesis in common. So now you can take out the x plus 3, and we have the x squared minus 4. I'm asking us to solve this. So what do you want to do? You have 2 parentheses equal to 0, so just set each of them to 0. So this gives us -3. How do you get rid of a square?
Square root.
And when you add a square root, you also need?
Plus or minus.
So we get x to be -3, +2, or -2. Was that faster than P's and Q's and synthetic division?
Oh, yeah.
Absolutely. Now, P's and Q's and synthetic division would have worked. We just, yeah, we recognize a faster method. We can use that. So if I asked you to graph this, that's stuff we've done before. What's my end behavior look like? It's degree 3, so down, up. What are my zeros?
-3, 2, -2.
Will we bounce or go through?
Through.
Through all.
Because they all have a multiplicity of 1, and 1 is odd. I also had you do the y-intercept when we graphed. Y-intercept is when x is 0. So if you plug a 0 in for all of our x's in the beginning, we get -12. So remember, all we really need is those zeros, and then we can graph anything. Zeros are where you hit the x-axis. Should start down here and end up here. We hit the y-axis at -12. We're going to go through all the zeros, so just come up and go through. And we know we can double check our graph on the calculator. I wanna ask you a couple more questions about this graph. Stuff that, again, we had done before, but, always is nice to see things a second time. If I asked you where this graph was greater than 0, could you tell me? Yeah, greater than 0, that means where the graph is positive, so that happens here. Yes. So remember, you give me the x's, there's no equal to, so we do parentheses. So -3 to -2, union 2 to infinity. So if I said less than 0, where's that?
-3.
Union. Mhm. So if you have a graph, you can answer where it's greater than or less than 0 just by looking at where it's above or below the axis. If I put equal to on that, what would change? If I said like greater than or equal to 0,
Brackets.
you get brackets. Okay.
Right.
Alright, so let's just keep doing some.
Is this the whole section?
This is it, that's all we're doing. So, nothing new here at all, just kind of reminding you how to solve some of these equations without going through the whole P's and Q's. So, on this one, P's and Q's would be an issue here. I'm freezing. There's really debating
Miss
turning out.
Williams' class is like 80, 90 degrees Fahrenheit.
Why would P's and Q's be a problem here?
There's no.
We don't have a constant here. What could I do?
X squared.
You could, your P is essentially a 0, but if I just wanted to factor this, they all have an x squared. So if I take that out, we're left with x squared minus x minus 6. So we could do box method. What two numbers multiply to -6 and add to -1?
-3, 2.
Okay, so what are my solutions? The x squared, that gives me a 0. What about x minus 3?
3, -2.
So that's what my x would equal. So we're probably not going to graph on all these problems today, because that's stuff we have been doing, but I thought we'd do a couple, just to refresh on a Monday. So what's the degree on this original one? 4. So what was our end behavior going to be? Our zeros are the numbers we get out. Technically, 0 would have had a multiplicity of 2 because of the squared. 3 and -2. So what's going to happen after 0? Any others? Y-intercept. If you plug in 0 for all of your x's, you get out 0. So are we remembering all of this? Okay, so both ends. Eli, you paying attention? Mm-hmm. So we go through the -2, hit 0 and bounce back, go through the 3, so it should look like this. Close. Alright, if I want to know when this one is greater than 0, Where is it above the axis?
Negative
Negative infinity to negative.
negative, positive, negative.
Infinity to infinity.
It's above the axis here and here. Right, what about less than? Where is it below?
-2 to 0, and 0 to
Okay. Do I need to keep practicing drawing the graphs on these? Okay, so you guys are okay if I just, for the rest of the examples, just review like the factoring and how to solve those things by factoring? Is that, okay. And if you have any questions, I'm certainly happy to graph any of them, but. Okay. So let's just focus on reviewing our factoring on these. What would I need to do?
Distribute x.
Yeah, as it's written, we wouldn't even be able to jump into p's and q's anyway. We would need to get our polynomial equal to 0. So, if we distribute, and then we want it equal to 0, I will write it in decreasing form. So we'll have 3x cubed minus 2x squared minus 27x plus 18.
now you can group.
Remember, we don't want to put a parenthesis after a negative, so I'm going to think of that as a negative 27. And then I'll put the first two together and the second two together. So what can you take out of the first one?
X squared.
And x squared.
That leaves us with 3x minus 2. What can we take out of the second one? 9. Now, we want this to be a positive 3x, so let's take out negative 9. And that would be a positive 3x minus 2. So grouping works when these parentheses match. So we're in good shape there. So now you take out the 3x minus 2, and we're left with the x squared minus 9.
Then you have some of the zeros.
Mm-hmm.
And then you get 2/3.
So positive 2/3. Get rid of the square, we do square root plus a minus. So positive 3 and negative.
Could I
And-
do a factor x squared minus 9 again, or?
You could also, yes. So x squared minus 9 is the difference of squares, so you could break that into x plus 3x minus 3 and get your zeros from there as well. So far, so good? I want to do just a couple more. And you guys are sure we don't need to graph on these? You know how to do that part?
And we don't have an x. There's 2 missing x.
There are 2
One.
missing x terms. Now we
Oh,
can
missing x terms.
certainly do p's and q's. Your p's would come from the 40 and the q's would come from the one next to the fourth. But there is an easier method. Grouping requires 4 terms, and we don't have that. Do we have a greatest common factor? No. But this is kind of like a box method problem. Because you could take x to the 4th and break it into what?
X squared.
X squared.
Minus 1.
You have 4 x's, so you put 2 of them with each. Multiply to negative 40 and add to negative 6.
Um,
10 and 4. Since we want negative 6, we have to do a negative 10
and a positive.
and a positive 4. Alright, so let's set these things equal together to 0. So that means x squared would equal 10 or negative 4. Square root plus and minus, can you break down the square root of 10? No. So we get plus and minus radical 10. This one, what's the square root of negative 4?
Plus or minus,
2i.
Right, so we can get imaginary zeros from here as well.
So if we can't factor our square root, we just write it.
Make sure you, like, if it's the square root of 8, break it into 2 radicals, break them down, but yes. So, do you guys think you can try one? I want you to do this problem. You don't want to just jump into radicals because you have x on both sides. So we need to set it equal to 0. We only have 2 terms, but what do you notice about them?
they could be factored to the next one.
Yeah, we can do greatest common factor, take out that x squared. That leaves us x squared minus 36. You can jump straight into setting these equal to 0 if you want. You could do difference of squares and break that into x plus 6, x minus 6. Either way, so what do we get for our solutions?
6 minus 6.
Positive 6, negative 6, and
1 and negative 2. Or 1 and negative 1.
if you set x squared equal to 0, you just get a 0, so, and a 0. If we were talking about graphing, we would have to think of that as a multiplicity 2. And as far as a test or quiz, just to be consistent, I want you to go ahead and put those multiplicities. I am going to tell you on the Math Excel tonight, I think there is maybe one that has a multiplicity, but if you type it in, the Math Excel counts it wrong. They just want you to list the number. Okay, so in general for me, I'm smart enough to figure it out. It's correct. But just on this Math Excel tonight, don't include multiplicities. Alright? So we are done. There's Math Excel assignment.